Okay, good morning all. So should we wait for some more time or should we get started?
I think we can wait for a couple of more minutes. See that there are very few participants until now.
Yeah.
I think we can start now.
Okay, then we'll get started with what we're going to do and all, and if people join in, of course,
Yeah,
it
sure.
would be good. Okay, good morning all, and so today's session is going to be on Redis and Celery. So before we get started, just wanted to understand how many of you have tried out installing Redis on your system? Yeah, the reason I'm asking is because I would be demonstrating how you can get Redis installed on your system, especially if you're on a Windows. So I just wanted to understand, like, has anyone tried it out? If not, you can kind of like follow on along in the session. So I'll kind of like adjust my pace accordingly. So would any one of you want to install or get your Redis setup up on your system if you're working on a Windows?
So if you demonstrate it, would be great.
Yeah, I will be demonstrating it, but at the same time, I want to understand if anyone wants to kind of like do it in the session along with us so that I can kind of like pace it accordingly because it would require some restarts to your system and all. So anyone wants to do it on the session along with us?
Yes, sir.
Is that a yes? Okay, if I know that a few participants are doing that, then I'm going to move really slow and I'll try to kind of like pace the session accordingly. And okay, so before we get started, how many of you are on Windows? Okay, 4, 5, 6, okay. Okay, so fairly a large number, right? So I see some, yeah, 7 hands in all. Okay, yeah. So yeah, I'll kind of like demonstrate the steps. I'll go a little slow, and yeah, I mean, before we do that, we'll just wait if anyone else wants to join in as well. And before that, we'll just try to get an overview, understanding as to what is Redis, what is Celery, and where does this fit in our scope of work in our application development, right? Okay. Now let me kind of like share my screen so that we get a fair understanding as to I'll kind of like try to kind of like draw and show where all these parts fit in together. Um, So, what is Redis basically, right? So, if you have gone through the screencast and the lectures of week 9, you would understand that Redis is basically a open source in-memory data structure. Yeah? So, in-memory means it kind of like uses your RAM, and in that sense, it's really fast. So, it's a data structure. A data structure which can be used for as a database, as a NoSQL database. It can be used as a cache. It can be used as a message broker. Okay. It's a really good thing, and we can make multiple. We can use it the way that we want. It can be used as a message broker. It can be used as a cache, and it can be used as a database at the same time. Now, when I say database, it's not a structured database the way that we would find it in SQL, MySQL, and all the the structured data structures. It basically tries to store things in key value pairs, right? So that's about Redis. Now, what is Celery, right? So, okay, let me open up a notepad or something. Okay, the system is a little slow today. I'm just trying to share my screen. Give me a minute. Okay, do you all see my screen?
Yes.
Okay, great. So now we are developing an app, right? So what you are trying to learn over here is kind of like a full stack development. You're developing your front end, you're developing your back end. Now, where does all this Celery, your message broker, where do they come in place, right? So let's say this is your front end, which of course you're kind of like creating with Vue currently. Now, your front end communicates with your backend in terms of like if it needs to fetch some information, and also in this case, the way that you are developing it currently, it's your Flask, right? So you've got your Flask as your backend over here. Now, at times, it might happen that the client, especially in big applications and all, right, it might happen that the client makes some calls which might take a while to fetch. So normally what happens? The front end will make a call to your backend, and the backend will is going to kind of like serve back those calls to us. Now, in scenarios, let's say the front end makes some request to the backend, which can take potentially some time. So we do not want to block, right? We do not want to block a server. So what we can do is this backend can kind of like delegate that task as a job so that it can be carried out asynchronously. And once it's done, it can notify back the user. So in the all the time, as soon as it makes that request, I mean the this thing can be freed up. They'll say that okay, your job is taken. It's going to work in the background, but we are kind of like freeing this up in the background, right? So it can still kind of like work on that task in form of a job. So that is where our Celery comes into picture. So our Celery would be somewhere over here. So if any of the tasks that are out here needs to work asynchronously, let's say we have to do some intensive processing, like you're importing some large files, or let's say you're doing some kind of background work with images and all, which can take some time. So we don't want to kind of like block our whole system during that time. So what we are going to do is we are going to kind of like delegate that as a job, which can happen asynchronously. And then it can kind of like later on be notified to our users, right? So this is where your Celery comes in. So with Celery, it's possible for us to create these async jobs, and which can kind of like work. We can create workers, and these workers, once they are done with the task, they can kind of like put in the results back to the front end. So in our Celery subsystem, again, we would require something called as a message broker, because all these requests that are coming in, they need to be kind of like sent out to the correct worker, right? So there might be a number of workers out here which are going to do a certain task for us. So we need someone who can do that job I mean, who can delegate those jobs to the workers for us, right? So that is where your broker comes into picture. Okay. So this is where we are going to have a broker. So what's the broker going to do? It's kind of going to take all these jobs which we want to be uh, kind of like handled synchronously. It's going to queue it onto the correct worker who can handle that work. And once that work is done, right? So that result can again be kind of like put into a backend, and that can notify back your either your Flask API, which can kind of like say, synchronously send it back to your front end or to your front end, whichever way we want to handle that part, that can be taken care later. So this is what we are going to see today. Yeah. So first thing, we'll try to get our, so in this case, in this example that we're trying to show, we will be using Redis as a broker. Okay. And Celery is what is going to kind of like help us create these workers and take those tasks. Okay. So while we are creating a Celery instance, we would need to specify a broker as well as our backend, which is going to kind of like hold the results of these tasks. So first things first, we will try to see for how do we get this Redis installed in our system. Yeah. Okay. So any questions still here, by the way? Anyone? Any questions? Okay. I'm audible, right?
Yes, ma'am, no questions.
Okay, great. So now coming to the fact as to how do we have Redis on our system, right? So Redis, I mean, with Windows, we have to go through the Windows subsystem for Linux, right? So first thing that you would have to do, we have to enable the Windows subsystem for Linux, because we cannot directly have, because Redis kind of like works on a Unix or a Linux kind of setup, and we cannot directly have a Linux setup on our Windows, right? So we have to go through the WSL.
We cannot see the browser window.
Okay, I haven't opened that yet, but are you seeing this? I'm trying to open this turn Windows feature on and off.
Yes.
Yes.
Yeah. So all of you need to, if you are following along in the class, just on your start on your taskbar over here, you can just type in turn Windows features on and off. So once you do that, okay, my system is absolutely slow today. You will find a box over here which says Windows subsystem for Linux. Okay, so you're going to find this. So what you need to do is you need to check mark this box. Did you all find it?
Hello, ma'am.
Even if you are not, yeah.
I just want to mention one thing actually. Newer versions of Windows 10, like version 2004 and higher, you can actually do that from the command line. Like instead of what you're saying is right now the old version how to install it, but in the newer versions, inside PowerShell, you can give a WSL install, and it will install that WSL automatically. I have put in the chat.
Okay, yeah. So there are various ways of doing it, right? So I think you should still see this in your control panel where you can go and check mark this in the boxes as well, right? You can do it through your CLI. You can do it through your GUI. Yeah, so whichever way you prefer. Okay, and whichever way you're comfortable. So there's no hard and fast rule that you need to install it this way or that way. But yeah. So what you said is also correct. You can also do it through a Windows, I mean, directly install it through your PowerShell.
Okay.
Okay. So after you do that, the installation, it would ask you for a restart. So is anyone actually doing it in the class? Yes, no, please. I need to know. I mean, if you're following along, I need to change the pace of the class. Otherwise, I'll just move along and tell you the steps.
Are doing it.
You're doing it. Is it asking for you a restart? It's installing it now?
I just says the required as completed, and it is not asking for restart.
It did not ask you for restart yet, is it?
Yeah.
Okay, but it will be required. Okay, so after you're done with this and you click OK, so we have enabled our WSL. So now the next step is to kind of like get this Linux subsystem onto our Windows, right? So you can head to the Microsoft Store, and in your Microsoft Store, you can search for Ubuntu. Okay, so there are various other Linux like Kali Linux and all, but yeah, I mean, let's just stick to Ubuntu for now. Did you all find this on your Microsoft stores?
Yes, ma'am.
Yes.
Okay, great. So just a few things to mention out here. This would not work on a secure mode. Okay, so if you have a Windows 10 S mode, it's not going to work. So I hope none of you are on a S mode, right? So if you're on a S mode, this installation is not going to go through. You might have to kind of like disable your S mode and then you can work it out. That should be fine. Yeah. So for now, if you've done that, you can go ahead and install this. And as you see, it's mentioned over here. I mean, of course, the first thing is that it's not going to work on Windows 10, and we needed to kind of like have a WSL on, which we have already done. And after doing that, it does require a system reboot. Okay, so without a system reboot, it's not going to take those changes. So you can go ahead and kind of like install it. Okay, so do let me know once your installation is done. And okay, so the thing is, if you guys are following along, it would require a system reboot as well. So before you all go and do the system reboot, just let me know so that I mean, whoever is in the class, we can still go ahead and kind of like discuss a few activity questions and all while you all join back onto the session. Okay. That works out for all?
Yes.
Okay, so is your installation still going on?
We have that as system command. Students have that. So I'm not sure how many of them are here.
Have what?
The Linux subsystem.
Okay, they already have it installed, you're saying.
Yes,
Okay.
ma'am. I've already
Yes, ma'am.
installed.
Okay, so you have already installed. So that's what I said. If any one of you is trying to install it along in the session, yeah, so in the meantime, before you restart your system, just let me know so that I'll just kind of like take the conversation on and we'll discuss a few activities while you guys join back. Okay? So in that way, everyone is in sync. Okay, so in the meantime, before I move forward, since some of you are trying to do it along in the session, I'll also kind of like start off with the activity questions, because it's best that after you install it, we do a system reboot. Just please let me know if the installation is done. Yeah, so I'll guide you on the next steps. So once the installation is done, you would see an open button like this. Okay, so you can go ahead and click open. And then once you click on open, you would get a command prompt as such. Okay, so in that command prompt, it's going to kind of like ask you to kind of like put in some username and password. So do those steps and try to remember your username and password. So Ubuntu kind of like whenever we are working on the sudo mode, it keeps pinging us for the password. So please ensure that you remember whatever password you give. Okay. So again, all of you who are following along, please let me know once you're done with this step. Okay. Now, in the meantime, so that we don't just have to keep waiting, we'll just go ahead and look at a few of the activity questions at the same time. Okay, so now the first question, right? Which of the following is the default mode available with Flask server? So Flask is a server, right? So what do you think? What do you think should be the default mode when we are talking of a server?
Multi-threaded mode.
Threaded mode.
Yes, exactly. Right. So, I mean, usually there is one server and there are multiple clients connected to the server. So it makes sense that, I mean, it has to be threaded, right? So otherwise it's not going to kind of like function properly. So great. Now let's move to the next question. Choose all the correct statements. Concurrency is achieved using context switching in a single core environment. In concurrency, one thread must be completed before another thread. Okay, so let's first kind of like look at these first two options first, right? Now, what do you think about the first statement? Is it a true or is it a false? If you are on a single core environment, and you want to kind of like achieve something like parallelism or concurrency, how can it be achieved? So do you think the first statement is correct or is it incorrect?
It's true. It's true.
Yeah, it's true, right? So, I mean, because the core can just work on one thread at a time. So if at all we have to kind of like achieve concurrency kind of thing, it can context switch between those different threads or processes. So that's how it can achieve it. So the first one is definitely true. Now, how about the second statement? In current and concurrency, one thread must be completed before another thread starts. So what do you think about that?
So for
Yeah, it has to be with context switching, right? So otherwise, it's not possible to achieve concurrency. If one thread has to complete and then only the next thread has to start, that's never going to happen. And in fact, that's the meaning of context switching, right? I mean, when we can kind of like can switch between those threads. So if we have to wait till one thread completes and then start the others, then that's never going to achieve concurrency for us. Okay. Now, coming to the next one is in parallelism, multiple threads can be executed at the same time on multiple processors.
That's true.
Yep, that is true, right? So if we actually want to have something like parallelism, that is, all the threads are working at the same time, that's possible in a multi-core system, right? And that is when in kind of like in a multi-core system, multiple threads are executed at the same time, but yes, on different cores, on different processors. So that is when parallelism comes into picture. Okay, so A and C is the correct options over here. Okay. And by the way, those who are installing, is the installation through? Please, I need to know that. Because you would require a system reboot. Okay. So if at all you are done with that part, just try to open your uh, Ubuntu. It'll ask you to put in your username and password. Do that part and try to restart your system. Okay, so in the meantime, it's nothing. We're just doing these activity questions. We're going through it. So you'll get ample of time to rejoin the session. Yes? Okay, how many of you are doing it? Please, can you just put your hands up? Am I audible?
Yes, ma'am.
Okay, I really need to know. If anyone is following along, I'll go at a slower pace, otherwise we'll move at the normal pace.
Yes, ma'am.
You're doing it, Priyanshu?
Yes, sir, I installed the Ubuntu one.
Okay, you're done. You need a, okay, so did it ask you for the username and password? Did you open the Ubuntu?
Actually, Ubuntu already installed in my Windows one.
Okay, you
So,
already have it. Okay,
yeah,
okay,
so
not
I'm
an
just
issue,
waiting
Yes,
for
not
the
an
ma'am.
next
issue.
instruction, what we have to do after the installation.
Okay, okay, then fine. Anyone else doing it afresh, getting Ubuntu on the system? Okay, I assume that's a no. No one is doing it. Fine, not a problem. So we'll quickly go through this activity questions and we will move on to our Redis installation part. Okay. So which of the following statements hold true for asynchronous tasks on a backend? Okay, so now all of you know what is an asynchronous task, right? And when it would be required. So if anything, any of the calls that the front end user makes, or in that case, if it's any kind of like timed kind of activity that the backend is trying to do, which might take a while, that I mean, those kind of tasks are what we push on to a job, and that's called as a asynchronous task. Okay, so having that in mind, let's try to answer this question. So which of the following statements hold true for asynchronous tasks on the backend? They are usually used to run asynchronously computationally intensive tasks. So is that a true or a false?
True. No, that's true.
Yeah, that's a true, right? So that's the main thing about asynchronous hours, why we need it. So if it's computationally intensive, we would require to push it onto a job rather than kind of like blocking the whole server and all. Okay. Now the next one, is it possible to have one front-end server and computationally intensive tasks are handed over to the task servers and notified asynchronously? So is that a true or a false? In the sense, it's asking whether it's possible to have multiple servers,
That's
right?
true.
It is true, right? So we can have a front-end server, and then you have other different servers which specialize in a certain task, right? So the B option is also true. Now, the user client only gets the response back after the task is completed. Is that a true or a false?
Actually, the user does get the response after the task is complete, but in the meantime, another task could run. So,
Yeah, so the thing is, we do not stall it over here. Okay. So as soon as the front end gives a request, which might be computationally intensive, but the backend tries to give some kind of response back. And I mean, it's no longer blocked out here. And in the meantime, it sends off the task to a kind of like a task manager, which can go ahead and push it on to the worker who can handle it. Okay, so the client gets an immediate response. It doesn't have to wait till the task is complete and then it gets the response. Okay, so in that sense, this wouldn't hold true. Got it? Yeah.
yeah.
Now the last statement, the web server and the task server need to be implemented in the same language. Yeah, what do you think on this?
Now we are in fact using Vue and Flask.
Yeah, so in fact, this web server that you have over here, the Flask, right? And all the, let's say, I mean, you're running backend servers over here as well. So they need not be in the same language. Okay, I mean, they can be implemented with whichever language it suits. Yeah, but we have to find a way of communicating between them. So this last statement doesn't hold good. Okay, so the correct answers would be your A and B. Okay. Now, coming on to the last one on this section, which of the below are examples of a distributed message queue system? Okay, so in fact, all of these are examples of your message queue systems. Amazon has its SQS. We know about Celery, which we are going to work on. So all these do hold good. Okay, so yeah, okay, we have another one. So when we have a distributed system, right? So what do you think are the challenges of a distributed system?
All of the above. All of
Yeah, so it can cause a deadlock, right? So if a message kind of like tries to go back and forth between two servers and no one is able to resolve it, or some one of it has gone wrong and it is waiting for a response from the other, a deadlock situation might happen. And if there is a failure, even if one server fails, it might be really difficult to handle it in a real-time distributed system, right? And security is always a challenge when you are kind of like having multiple servers and multiple um, machines to look at. And of course, your answer has to be all of the above. Okay. So we're done with 9.1. So let's quickly move on to 9.2. Okay, so which of the following hold true for the messaging queue? Okay, so when you're getting your task from the backend, they have to be sent out to these workers, right? So usually a broker queue takes care of that. Now, with respect to that, what do you think are the correct statements? It follows a last in, first out approach. How does a queue work? In general, when you hear of a queue, or if you have learned all those algorithms on data structures, right? So, what is it in queue? How does a queue work?
first
Does
in,
it
first
follow? It's a first in, first out, right? So LIFO structure wouldn't work out over here. So the first statement isn't true. Now, sending a message is decoupled from processing the message. Is that a true or a false?
I didn't get the sense of the statement itself. Actually,
Okay,
decoupled in a sense,
so
is it detached or independent, are they both the processes independent?
yeah, it's kind of like
Is that what it?
you can think of it like yeah, decoupled. They are independent of each other. You can send a queue, but you're not bothered whether the queue, I mean, the processing is being done immediately or not being done immediately. Okay, so that's the whole purpose because it has to still wait. So let's say this is your broker queue. It still has to wait. If this worker is processing something, it's holding that message for you over here, but yeah, it still has to wait till one of the worker is free, and then it can take that and it can kind of like push that message onto this worker so that it can do it. And after it's given the message, it doesn't have to bother, right, whether this worker has done its task or not done its task. So it's kind of like decoupled, right? So it's independent of each other. Okay, so this is definitely a true. Now the communication is synchronous. So till here, what have we been talking? Is it synchronous when we are handling message queues and all?
No.
No. The whole purpose is whenever we have to handle something that needs to be dealt with asynchronously. So point C is not at all a true statement. So our only answer would be B. Okay. Now coming to the next one, what are the benefits of a message queue?
All of these.
Okay, it shouldn't be all of these actually. Okay, I guess some mistake over here. Okay, wait. ठीक है. Yeah, it's all of these. Yeah, so it is scalable, right? So we can easily scale things up when we are handling different kind of tasks over here. So we can put in multiple servers and it can do things pretty well. And in case we have to do a batch processing, right? So that's also possible using message queues. It can hold all the same kind of requests together and send it out across in a batch. And of course, they allow us to easily monitor the same. And yeah, so the answer is all of these. Okay. Now, coming to pub sub messaging. Now, this means publish and subscribe messaging kind of thing, wherein there is a publisher which publishes a message and it kind of like works out like a broadcaster. Okay, so it is broadcasted onto the subscribers. So, with that, right? So, what do you think? What are the correct statements?
1, 3, and 4.
1, yeah, so it is known as a publish and subscribe. The publisher can broadcast messages to selective subscribers. Okay, so that is not done. So the publisher's job is just to publish it. It doesn't care. I mean, whoever has kind of like subscribed, it's going to go to all. There is, I mean, the publisher doesn't have that. They can broadcast. I mean, selectively choose whom to send it to. So B is not an option. Then the message filtering is possible on the subscribers end. So the subscribers end, it's possible that they can filter out, okay, if they don't want a message from a certain publisher, they can filter it out at their end. Okay, but it's not possible from the publisher's end. And finally, the publisher need not be aware of the subscriber. Okay, so the publisher is totally independent. So how many people subscribe, who has subscribed out there? So it's none of the job of the publisher. It can simply broadcast the message and it goes out to all the subscribers. Okay. Now the next one, which of the following statement is true? So AMQP, does it stands for Advanced Message Queue Protocol. Is that a true or a false?
It's a true.
Yeah, so that's a true. Now it standardizes the messaging using producer, broker, and consumer.
That's also true.
Okay. And RabbitMQ is an implementation of AMQ.
Yes.
Yeah, so Rabbit Broker is another kind of broker, and it is an implementation of our advanced messaging queue system. So all these A, B, and C holds good. Okay. Now we'll quickly finish activity 3 and 4, and then we'll move on to Redis. Okay, so now let's see this. So in a point-to-point messaging, right? So what do you think are the correct points? There is one-to-one correspondence between the message sender and the message receiver.
Yes.
Yeah, so as the name is suggesting, point to point. So obviously this is quite obvious that there is a one-to-one correspondence out here. Each message is consumed only once.
Yes.
Yeah. So each message is processed multiple times.
No.
It should not, right? So once you send it, if it needs processing, it should be done kind of like in the point-to-point one, it should be done just once. And message sender must know the receiver.
Yes, because point to point.
Yeah, so it's a point-to-point, so that one is also true. Now, which of the below are some Redis modules? Okay, so now if you look at Redis, okay, so Redis is quite a vast thing. Again, if you look at Redis, Redis does provide us quite a lot of modules. Okay, so let's see one of the examples over here. So I would want you all, like whenever you get some free time and all, just go through these terms so that, I mean, although we may not be using it in our projects, but it's always going to be good to know that what are the things that Redis provides, what all is possible to do using Redis and all. So it has this module. So inbuilt it doesn't come, but of course, if you go ahead and install this particular module of Redis, then it's possible for you to get a Redis time series kind of data structure as well. Okay, so in fact, it provides various modules out there, and all these are examples of your Redis modules. In fact, they say using this Redis ISQL kind of thing, it's possible to get a structured kind of database as well, which is by de facto not a thing of your Redis, right? So all these are your possible Redis modules. Okay, so yeah. So these are kind of like good to know things which you should know. Is it possible, not possible, and all. And of course, if at any point of time, if you're implementing something and you need something like that, you always know that it's available and it can be done. Okay. So again, for this, all of this is an option. Okay, so we're done with 9.3. So 9.4, let's quickly look at that. Which of the following statement is true regarding a pull queue? Okay. Now, pull means you are kind of like trying to pull the information, right? So let's say it's a pull queue. So what do you think is going to happen over there? Is the server going to pull, or is the queue going to kind of like give the messages to the server?
It's on the client side though, so client will pull the messages and server will just produce and push it to the queue.
Server. Okay, so let's
Not
say
the
you
client,
have,
but the consumer.
yeah, the consumer, right? So let's say we have a queue over here, right? So if this was a pull queue kind of thing, we would expect that the server goes and polls this particular queue at regular intervals. Okay, and is it possible to kind of like pull queues are useful for batch task to batch tasks together? What do you think? Is that a true or a false?
That should be true. Like I forgot from the day I did the MAD assignment. So I think that should be true. We can batch tasks together.
Yeah, so we can actually do it. We can batch tasks together, and the server can poll and again take those tasks at regular intervals. If they are already batched together in as tags, the server can pull those requests at once from the queue. So in this case, as we see, all of the options should be true, right? So tags are also used to group related tasks. Okay, and now, okay, so if you have gone through all the lectures, so what's the default port for Redis?
6379.
6379, right? So this is the one. Okay, so we're done with 9.4. So let's move on to the Redis part, and if time permits, we'll come back to the practice questions. Okay. Now, coming back to your Redis, so if all of you have your Ubuntu in place, then the next step is to install your Redis, right? So to install your Redis, we first need to do a couple of things. So one thing is that we have to have our net tools in place, okay? Because this kind of like comes as a package. So we just have to ensure that our net tools are in place. So what you all would need to type in is sudo apt. So I hope you all know these terms, right? What sudo is, what apt is, and all.
Yes, ma'am. Can I ask one another question regarding the project?
Project. Okay, so
Yes.
for project as such, we will be having exclusive sessions. If possible, we're
No,
trying to arrange. Okay,
it's just
just
a
a general
simple
question. You can
question.
go ahead. Yeah, go ahead. Yeah.
Yeah, it was mentioned that we should be able to emulate Linux, but I am using Mac and it's POI6 compatible. So is that fine?
Yeah, shall I answer this, Sanjita?
Yeah, sure, sure. Go ahead.
Yeah, actually, means that instruction was given because Redis doesn't directly work on the Windows. You either need to install the WSL or have some kind of VM. So yeah, if you are able to run the Redis server, that is completely fine.
Yeah, sir, I'm able to run on Mac using Brew.
Yeah, of
So
course, of course.
it's
Yeah. Sure. Yeah, you
okay.
can do with it.
Okay, sir.
Okay. So sudo essentially stands for your super user do, right? So I mean, if we have to do some things in kind of like the supervisor mode and all, right? So that's when we use sudo. And apt is your advanced packaging tool. So in case, just the way that when we are installing packages on your Python with pip or on your Node.js with npm, right? So out here we have our apt. And okay, so as I said, the first tool that we need to have if we have to go ahead and install our Redis is we need to install our net tools. So if you people have done this before, of course, you need not do it. You can just run a apt update. So this is the command that you all might want to try out, apt tools. Okay. So it's kind of like a collection base of networking utilities for Linux. Okay, so we need to have this. Once, since I already have it, not trying to run it again. Okay, so once you have done that, you just might want to try to update all of these. So you can do a sudo apt update. After doing that, you can go ahead and install your Redis server now. So for that, it's straightforward. It's simple. You can do sudo apt install Redis server. Okay, so this is what you need to do. So once you've done that, it might take a while, a few minutes, I mean, especially for running your net tools and updating that. But the Redis server shouldn't take much time. And that's all about the installation part. Okay, then your Redis server should be up. Yeah, everyone clear till here?
Yes.
Okay. So once your Redis server is there, you can type in Redis -server and okay, I'm not typing in Redis, it's not responding. Okay, once you type in Redis-server, this is how it's going to start up. Okay, so you would see something like this on your terminal, and you would know that your Redis is up. Got that? So once your Redis is up, now you can ping your Redis. Yeah, are you guys trying it out?
Ma'am, how to ping?
So as we see over here, it runs on your port 6379, and yeah, we should be able to find it on our local machine. Okay, so my server is up over here. I'll just clear this. Now, once you have started your Redis server, now you can open your Redis CLI. All you need to type is Redis-CLI, and you would get a prompt like this. And now you can
What did I
interact Redis-CLI. Have you opened a Redis server? Is it working?
I installed actually.
Okay, you installed it. After
Yes,
that,
ma'am.
just type in Redis-server,
Sorry, Redis.
Redis-server.
Okay. Yes, ma'am.
Yeah, press enter. Do you see your Redis server coming up?
Yes, ma'am.
Okay, so now your Redis server is up. Now you can just go to another prompt and type in Redis-CLI. Then you would get your Redis prompt out here.
And we have to open another instance of WSL.
Yes, you can
And
open
over there,
another
we have
instance
to
of your
type
Ubuntu.
Redis
Yeah,
dash. Okay, yeah, got it.
got it? It's up?
Yes.
Okay, great. Now you can communicate, right? So if you say a ping with some message, let's say hello, it's going to respond back with that message to us, right? Or if you just type in a ping, it's going to kind of like send across a pong. Got it? Everyone tried it till this point?
Yeah.
Okay, great. So now, I mean, you have your Redis now, right? So your Redis is there. It's on there on your subsystem. Okay, so now let's just try out a few commands on Redis. So as we said, right? So everything is in key value pairs. So when we want to kind of like make use of Redis as a database, so essentially it tries to store things in terms of a key value pairs. And in fact, it does support quite a lot of data structures that you can have. The default thing is kind of like we can have our strings, we can have lists, we can have sets, we can have hashes. So by hashes over here, I mean when you want a JSON kind of object in your structure inside your Redis, right? So that's also possible. And of various other ranges also it does provide us, right? Like bitmaps and all that. But yes, I mean, we do not need to go into those details. But yeah, let's just try out a few commands so that we get a hang as to how things can be done. So the good thing is this is not case sensitive. So you type in a capital SET or you type in a small SET, it would still work, right? So whenever you want to set a certain key against its value, we have to use the set keyword. Okay, but by default, yeah, let's try to use the caps lock. It makes things understandable. Now, let's say we want name, and yeah, so let's say we want to store a name. Let's say John. And there you go. It says that this name is set, right? Now, how do you retrieve the value? How do we know that? So over here, name is your key and John is the value that's stored in it, right? So now if you want to kind of like go ahead and retrieve this information back, we just have to use the get command in this case. So you say a get followed by the key name. And as you see over here, it is giving you the hints, right? What is it that it's expecting? So in our case, we want name. So you type in name and it's giving us back John. So as you see over here, usually things are stored as a string over here, right? Now, let's say we go ahead and store some other information. So let's say from which place this person belongs, right? So we'll say India. So we have set that. Now, in order to get it, you say get followed by the place. Now, how is it that you're going to know, right? What are the key value pairs that are stored out here? So you can just type in key, keys, I guess, keys, and give a star. So it's going to show you all the key value pairs that you have. So we have name, we have place. So it's saying that, okay, these are the keys that you have in your database currently. Okay, so this was about your get and a set. So let's say you want to kind of like check out whether something is existing. So you can use out your exist keyword. So something similar to your Python, the OS module, the commands that it gives, right? So something similar to that. So you give exist followed by the key name. So let's say exist name and it says a 1. So that means that this key is existing, right? So name is existing out there. Now, let's say you want to kind of like go ahead and clear off everything. Okay, we'll do that later. Before that, let's try out a few things. Now, TTL is time to live, right? So if you give TTL followed by the key name, so what is it saying? It's saying that it's an integer of -1. So what does this -1 signify? Any one of you? What do you think? This is time to live. Okay, TTL is time to live. So if we are, it's showing us, sorry for that. If it's showing us a -1, what do you think it
It
means?
will continue existing forever.
Exactly. So it's a persistent data. Okay, so it's not going to expire. So by default, when we are trying to set things, it kind of like has it as a, it's persistent, right? So it's showing it as a -1. That means it's not going to expire. But in case we want to kind of like set it for a certain interval of time, then we can always mention that interval. So we can say expire, then we can give the name of the key. So let's say name, and let's say I mean, as it's showing, it's going to keep it in seconds, right? So I give expire name 10. So now if you try out a TTL, it's going to say, okay, I didn't give the key name. And so it's saying -2. So that means it's already expired now. Yeah. So 10 seconds are gone and it's already expired there. So let's try out a get name. So now if you do a get name, it shows you a nil, right? So it's saying that it's gone because we set it to expire. By default, if we hadn't used the expire keyword, it would have persisted forever. But if you use the keyword of expire, that is where you can attach a time limit for which you want that particular data structure to exist. So this feature you might find it useful if you're trying to use Redis as a cache, right? So that's where you can say that, okay, you want this thing to be present for a certain duration, let's say 1 hour, half an hour and all. You've set the timings accordingly. And after that, it's gone, right? So that's where you can make use of this expire feature when you want that particular thing should exist for a given amount of time only. Okay. And in case you just want to set the expiration time as you are creating the key itself, that's also possible. You give a set ex followed by the key name. So let's say I'm just trying to create the name again. And next thing that you have to give is your value for which you want it to live, and then you go ahead and give the name, right? So let's just try to give in the same name again. So this time we have said that it is going to live for this many minutes. So let's just try it out. So it's giving us, after 20 seconds is gone, it should go off. Okay, 20 seconds isn't gone, is it? So finally, it's giving us a nil, right? So what are we seeing? That after 20 seconds, we are no longer able to retrieve the name. So while setting your name at all, you want to kind of like give the expiration time in one go, you can always use this particular command, set ex. That is, it's going to set it along with the expiry time. Okay, clear till here? Any questions till here? Yes, no?
No.
Okay, great.
Yes,
If we do just the set key, then it will set it for forever, right?
Yes.
And
By
but if
default,
we
what we are saying is, yes, correct. Yeah, so if you just use the set key, it's going to be a persistent thing. It's not going to go off. But yeah, if you want it to kind of like expire after a certain given amount of time, you use this keyword followed by the time and then followed by the value. So likewise, you can create lists as well, right? So let's just try to create one or two so that I can just show you. And so for that, we can use the push command. Okay, so you give a L push followed by the key. So let's say we want to create an array of places, and you give a value, right? Okay, so it is set. Yeah. Now, if you want to kind of like, let's try to push something else also. Mm, okay, so let's say US. So let's say, as you see over here, the numbers are specifying, okay, how many items you have in that list. And in case you want to kind of like go ahead and see what are the things that you have in the list, you can use your L range command and followed by the key. So in this case, our keys is places, followed by the, I mean, obviously over here again, it works with indexing, right? So we have to give the index number through which we want to see. So let's say we want to see everything, right? So we can give the starting index, which is going to be 0. And let's say you want to see till the ending, right? So we can simply give it as a -1. So it's going to go till the end. So what you see out here is that it has, the places has these two things, US and India. Now, if you notice over here, I had given L push, right? So it tries to push to the left-hand side. So if you look at the order, right, it is, I mean, first we pushed in India and then we pushed in US. But what are we seeing? We're seeing US first and then India. But let's say you want to kind of like push it in the other way around, you can use something called as your R push as well. So you can give R push. So, and let's say, okay, our key was places, right? So in places, we try to put in UK now. And let's try to use the R range command again. You see this time, it's pushed to the right hand side. We are seeing UK at the bottom now. We are not seeing it in the front. So yeah, so those are some of the functionalities that you have in terms of your list. So that's your, you can use L push, you can use R push, and in order to see the things that you have in your list, you use L range. And likewise, you have your, I mean, if you want to kind of like pop some information, so pop, we know it always kind of like takes it from the end. So you can specify which end you want to take it from. So if you give L pop, it's going to take it from the left side, right? So if we give L pop places now, so which element should it take it off? Should it take out? Yeah, anyone? What do you expect? What do you think? Yeah. So it's taken out the leftmost element, right? Now, likewise, if you didn't want that, you wanted that it should take it out from the right side, you could use your rpop. So it's going to kind of like take it out from the right end. Okay, so this was about your list. So first you saw strings. So for the strings, you can use your normal set and get. Then for your list, you can use your lpush, lrange, your lpops. And now let's just have a look at hash, and then we will see how we can integrate our Celery and our Redis all together in our application in a Flask. Okay. Okay, so now hash. So as I said, if we want something as a key value pair, right? So we want to, let's say we want to create something as country, right? So in
And
country, yeah, tell me.
in the list, is there any way to get just the number of elements we have pushed in the list without printing the or without adding the
Uh,
new one?
I think the L length should be there. Yeah, it's showing, right? So L length, and you give the key. Okay, so we have just one element because we have popped out US and UK, right? So only India is left and it's giving you the integer value 1.
And the list name of the list we have created, I don't remember the places that I've created the places list. Is there any way to get that? The names of the list.
Names only of the list. Okay, I'm not pretty sure, but okay, why? If you want to see all the things that you have, you can always give a keys star,
Yeah.
right? And it's
Yeah.
going to give you that.
Got it.
Okay,
Yeah.
yeah. So now hash. So what does hash essentially mean? Whenever we want to kind of like have a JSON kind of structure, yeah, so that's where we can use our hash. So let's say we want to have a structure like a person, and we want to put in the name of the person, the age of the person, or let's say students, right? So we have been dealing with the student data structure for such a long time. So we want to kind of like store all the details of the student, right? The name of the student, the ID of the student, the courses that the student has taken. So in that case, a dictionary kind of structure or a JSON kind of structure helps us, right? So for that is where you can use your hash. So how do you set something in hash? You can use your h set, right? H set followed by your key name. So let's say in this case, we are handling students. So that's our the thing. And then we can give the field name within. So let's say we want a name, yeah. And next, you want to go ahead and let's give some name. Let's say Ram. Okay, so now how is it? It's going to have students. Inside students, it's going to have the name. Now let's say we want to add the ID as well. So under students, we can, I'll just change this to ID. So that's going to be the field. And let's say this person has a ID 1. Yeah, so now under students, you have both name and ID. So if you want to kind of like go ahead and see what all you have inside this structure, so you can just give h get all followed by the key name. And in this case, our key name is students. Okay, so it kind of like, yes, it shows it in this structure. So you have to understand that the first thing it's giving is the key, the value associated with it. So name followed by the value which is Ram, and ID followed by the value which is 1. Okay, clear till here, everyone? So these are few of the data structures that Redis supports that I've just tried to show you: your strings, your hashes, and your list. So these are just some of the basics, good to know things which you can kind of like do with Redis and all. And if you do a key star now, you would see that students would also be added on to this. Yeah, so we have students out here. And in case you want to clear off everything from your from your database, you do a flush all. And now if I do a keys, you see that empty. Okay, so we do not have anything, it's empty and it's all gone. Okay, so I'll just clear it off. Yeah, we are good till here. Okay, so now let's move on to seeing how we can integrate, right? So what we want to integrate the celery onto our flask, right? So how that can be done? Let's just take a small example and we'll try to show you. So I'll just try to show you how you can do it on your local setup. And if time permits, Abhishek will try to show you how it can be done on your Replit kind of setup as well. Okay. So, okay, so let me see. Yeah, so I have just created a empty directory out here and I've just added the virtual environment over here. So what do we want to do? We want to kind of like integrate our Celery or make use of Celery in a Flask, right? So in a Flask kind of structure, how we can kind of like from within your Flask APIs, how is it that you can go ahead and create a Celery task and how you can make use of it. So let's have a look at that now. Okay. So in here, I'll just go ahead and create a file. Let's call it app.py. I just have my virtual environment set. Yeah. So that's all. Now, we are going to use Flask, right? Okay. So first thing, let's just kind of like create a simple Flask thing and let's try to get that up first. And then we will see where the Celery part comes in and how we can put in Celery. So from Flask, what do we need to do? We need to import our Flask. Okay. Now let's just install our Flask as well. So I'm already in the virtual environment, and if I do a pip list, obviously we haven't put anything till now. So it would just show the de factos, the pip and your setup tools. Now let's go ahead and do a pip install of Flask. So pip install. Okay, so now we have a Flask in place. And along with Flask, we get a few other dependencies like the Ginger and all. So all that is in place now. Now let's just create a simple app, which basically of now will do nothing. So okay, let's create a route. So let's say app route. Let's create the home route first. Let's simply call it home. And what do we want to do? Nothing much. Let's say hi from. So let's say this is coming from our Flask, so that we can kind of like differentiate when we kind of like try to use our Celery worker as well. And finally, we have to go ahead and run our app, right? So we'll just do if. Yeah, in case anyone wants to try this out, I'll just show a quick one. Yeah, so you can move along and try it out as well. If your Redis installation is up and all, you can as well as try this out as we are moving along in the session. So we can do app.run. And let's just try to keep the debug mode as true. Okay, so let's kind of like quickly run this. So we have a Flask up now. Yeah. So next thing, what is it that we want to do? We want kind of like get our Celery in place, right? So that we can kind of like create a Celery task, and we are going to use Redis as our message broker out here. Now, in order to use Celery in your Flask, if you look into the documentation of Flask, we will find this. Okay, so if any of you want this link, I'll share it on the chat as well. Okay, so I've done that on the chat. So what we basically want is, in order to kind of like have our Flask module use Celery, we would need this piece of code. Yeah. So what I'm going to do is I'll simply first of all copy, paste this part of code, and then we'll try to understand what is it that it's doing. So I'm going to create another file. Let's call it Flask underscore Celery maybe. And in there, I'll just paste this part. We will not update it from here. We'll try to do that from our app itself. And of course, as you're seeing over here, it does require us to import our, install our Celery as well as a Redis. So let's do that. So we'll do a pip install of Redis. And our Celery. And of course, when you are creating your projects, you can always create your requirement.txt and add it from there directly. So since it's just a small demonstration I'm doing over here, I'm directly just trying to install the thing. So any questions from this point? And of course, now if we just go to our pip list and try to see, we would find that our Redis as well as our Celery should be installed. Right? So we've got our Celery 5.2.3 out here, and we should have our Redis as well. Yeah, so we have our Redis out here, 4.1.4. Okay, so now all the things that we want are in place. Now, looking at this, right? So if you look at the documentation, the explanation for the same is also given out here, right? So what does this do basically? This function creates a Celery object for us, right? So the main thing is that we have to create a Celery object and use it in the instance of our, call it in the instance of our application. Yeah, so that's the main thing out here. So we are trying to create a Celery object. And what is it doing? It's kind of like it configures. So in order to use Celery, we need to configure a broker as well as the backend. Right? So that's why you see these configurations over here, Celery result backend and Celery broker URL. Those are two things that we will need to specify, which we will do it from our app.py. And after that, we have to use this, right? So it kind of like from Celery task, it tries to create this context task, and we are going to use this context task. So that is what we will try to return. Yeah. So now we have to make use of this in our application. So I'll just go back to our app.py, and in here we will try to import our Redis, so because that's what we will be using as our message broker. So I'll just give import Redis, and next I'll try to import this file as well, because we are creating our Celery object in this particular file. And what do I want from here? I want this make Celery, right? So that I can create an instance of that in the file out here. So over here in my app.py, okay, So the file name that we have given is flask_celery, right? So from flask_celery, what is it that we want to import? We want to import that make celery. So import make celery, right? So now we have done that. Now, having done that, what we need to do? We need to kind of like configure the backend as well as our Celery broker. Yeah, so we will just try to specify that as app configs, and we are going to update it. So I'll just give app.config.update. And now what is it that we want to update? We would want to update our Celery broker_URL, right? I'll just take this from here maybe. So this is something that we want to specify. And in our case, let's just kind of like, I mean, it's running on 6379, right? So we'll just take that. So what we have to mention is Redis, and it's running on a local host, right? So we can give local host followed by your port number. So in our case, the port number is 6379. Okay. And now what we also, let's say we'll have this as our backend as well. I'll just take a name from there. And we will try to keep this as a backend as well. Okay. Now we would have to create a Celery instance for ourselves, right? So we are going to make use of this make Celery. So I'll say what is our Celery? Our Celery is nothing but make Celery. And yeah, we want to run it from our Flask. Okay, so now having done that, let's see how is it that we can create a Celery task, right? So let's say we want some kind of computation. So over here, let's just take a simple case of printing out something, right? So let's say we'll just print out the name hello and just try to see, or later on we'll see how we can take parameters as well. Yeah, so let's just start off with a simple just showing the result name itself, right? I mean, we'll just try to show a print statement, that's all. Okay, so for that, we have to say that it's a Celery task. So we have to use this decorator, right? So add Celery, so it recognizes that, okay, we have created this Celery. Then you have to give a dot task. Okay, so that's how it knows that it's going to kind of like create a Celery task. Now we can specify the name of this task. Yeah, so you can give it some name. So when we are running a Celery worker, you will see that that name comes up over there. It will show that, okay, these are the tasks that it has. So I'll just give it some name. So let's say that we're just displaying something, right? So I'll just call it display. And now we have to define just the way that we were defining. We're using a decorator, and we were saying that what that was supposed to do. Over here, the same way, we're using this decorator. Now we have to say what is this task supposed to do, right? So we will define a function over here. So let's say, okay, so it just has to display something. Yeah, so let's call it display only. And we won't take in any parameters as such of now. And yeah, so what we can do is we can just ask it to return, let's say mat2. Okay, so it's not going to do anything. It's just going to try to display this thing for us. Now the thing is that how would we call such a task from our route, right? So how can we call a Celery task from our route? So let's just try to see. So it's fairly simple enough. All you need to do is Let's try to create another route for that. And let's say we call our route display. Okay, just to differentiate, I'm giving it name, and then we shall define it. Call it the same thing. And what do we want this to do? We want this to in turn go ahead and call this particular Celery task, right? So we don't want it to do anything else. We just simply want it to go ahead and call this Celery task for us. So we can simply go ahead and do that. So all you need to do is call this name display, which is this name. Then you have to use a keyword delay, and that's all. Since we do not have any parameters and all, right? And this can return back, right? So we'll just say that it's running a asynchronous task for now. I'll just type in async. Right? So what it's going to do, it's going to hand over this to the Celery task. And what should the user see? The user should see that, okay, it has got back some return message. Okay, so that's all that we want to do at this point of time. So let's try to run this. We'll just restart our Flask. Okay, before I restart the Flask, I'll just try to run the Celery instance as well. So for that, now we have to kind of like run our Celery. Okay, so that we can spin this create a worker which can handle this task for us, or it's going to kind of like create those different. So let's say we had a number of tasks. It's going to kind of like show us that, okay, these are the tasks that the Celery is going to handle, right? So the command for that is Celery. Then we have to give a -a. We have to provide the name of the file where we have all these Celery tasks. So in our case, it is app, right? And just in order to differentiate whether it's a kind of like running a default Flask kind of thing, or it's trying, I mean, we are just interested in this Celery task part of it. I'm just going to add that as a .celery so that we don't run into unnecessary errors. And then we want to say that, okay, we want to start a worker. And next, we want to see all those logs and informations, right? So we can give a -log level. So this is how we can kind of like see all those, keep track of all those informations and how, whether it's receiving a task or not receiving a task and so on, right? So you give a -log level equals to info. Okay, so let's run this. Okay, so if you see over here, right? So it's giving you your app ID. It's giving that, okay, this is what, I mean, by transported means your transport queue, right? The Redis broker queue, which we had mentioned. It's showing, okay, this is where the results also need to go to. It's showing that path as well. And over here, if you see, we just have one task for now, right? So what we have created is this one. Okay, I've misspelled it on the same, but yeah, and you are seeing that over here, right? So it's showing you app dot display. It kind of like knows that this is the name. It's picking up. Got it? So you are seeing that task name out here as well. Got it? So now our Celery is in place. Our Flask is also in place. Now let's try to make a call. And what had we named our route? Display name, right? Happened. Okay, how did it start? So you see over here, we are immediately returning back saying that it's a async job. That is what we had mentioned in our code, right? Although this is going to go into a task. Now, if I open up Celery, is it stuck or something? Now, if you see over here, it's saying that it has received the info out here, right? So it's giving us a job ID and it is saying that it is received as well. So let's say you want to kind of like display that instead of just returning a async, you want to show that job ID out here. So we can do that as well. So if you give job equals display.delay, and what we are going to return is we are going to return job, but okay, so we will run into an error over here, I guess. It will run it, so it's going to be an error. Yeah, so you see it's giving a type error. So as in the beginning we were saying, right? I mean, the Redis by default it tries to show store things in form of a string, right? And so in case we want to kind of like return this job over here, we just have to mention string that we don't get that error. So now you see over here, we are getting that job ID over here, right? And let me see if we can return Redis as well. So over here also, since we are using all this Celery for storing things, we are seeing that all these are created. Because if you remember, I had cleared off everything, right? And since we have kind of like connected our task and all, we are seeing all these informations out here. So this is a very simple setup in which at least, I mean, you get the basic idea how a task is created and how you can run your task from your Flask, right? So this is how, I mean, of course, your logic is going to be different. You might have to run something, I mean, where it makes sense. Obviously, just displaying a name in a job kind of thing doesn't make sense. But yeah, if you have to do a number of database inserts and all that, so those are some of the use cases in which you can do it. But at the same time, now you know how it can be done, right? So you create a Celery task, and from your app route, you can call your Celery task using your display. Or I think you can also use your async function for doing the same. And you can always kind of like go ahead and get your job ID back. And in fact, I mean, in this case, it's a very small thing. You can also wait on it and get the result, but that's not the whole purpose of the thing. We want to get things asynchronously. Okay, so that's it from here. So Abhishek, would you get time to show it on the Replit setup? Is it possible? Because we hardly have
Maybe I
20
can
minutes.
quickly walk through a very quick overview on a very high level as well. So it is also
Yeah.
possible to do or to simulate a similar kind of setup on Redis as well, but it will require some extra amount of work.
I'll stop
That means
sharing
your
my
project
screen.
can also be built on Replit if you want, but we'll highly recommend you to do it locally, as there are various implications of doing it on Replit. But still, just for your knowledge, we'll try to demonstrate a small part of it where we will integrate a Flask application with this Celery part. I'll just quickly share my screen. I guess in one of the lecture also, Professor Nitin demonstrated some part on how you can use Celery workers on Replit using Nix. Right. I will be just continuing from there as well. Let me just share my screen.
Abhishek, my screen share is gone, right?
Yeah,
Because
yours
I
is gone,
didn't.
I guess.
Okay, yeah, great.
Is my screen visible now?
Yes.
Okay, great. I'll just quickly go to Replit. So we'll be creating a RAPL for this Nix here. And yeah, let's name it as sample salary. So once this project loads up, it will give you these 3 files in the beginning. One is this readme that will give you some exposure of what this is all about, and these 2 files. So if we want to work with Celery, if we want to work with Redis, we need to have all of those dependencies installed in our environment. Right now, we have nothing apart from this COBSA. So we need to install all of those dependencies that I just mentioned, Redis, Celery, even Python as well. So there is basically a documentation or a simple tutorial from Rapid Docs that I will be sharing the link of in the chat. Just a minute. Okay. Yeah, so this will give you some exposure of how you can get started. I'll share this link in the chat as well for all of your reference. So what will I do is I'll simply, take all of the dependencies, right, that we need to install in our environment. So I'll just copy it from here and I'll just replace it. Okay. So what this will do is this will install all of the things that we have written here. So the Python, the Flask, there are some other things as well that we don't want in this demonstration, but I'll just leave them as it is. If you want, you can remove them too. So once I will click on run, it will install all of the dependencies, and what will it do is it will run this command and it will show this welcome to the Nix on Replit on the console. So I'll just click on run. Just a minute. Okay, I deleted it. Okay, so yeah, that is done. Now, what we need to do is we first need to set up Celery. What will I do is I'll just first set up Celery. After that, I'll create a Flask application to integrate it with it. So if I want to create a Celery application, of course, we will be doing it in Python, and we have already installed the Python here in this environment. So I'll just, just add one more file in this layout, and let's name that file as Celery.py. And if we are writing some task in the Celery, we know that we will have to, of course, means install the Celery first in order to define the tasks. So we need to basically install it. I hope I'm not making any typo here. Right. So I have imported it. Now I need to create an object. I have just imported Celery class. I need to create an instance of this class so that I can instantiate this Celery object. So what will I do is I'll simply say that app equals to, well, I'm habitual with app. You can name it whatever, anything you want to. So say Celery, and here you can give any name to it, just the way you usually do it for while creating a Flask instance. Can name it anything, whatever you want. Right now, I'll just give the same name as that of file name. But yeah, as I said, you can name it whatever you want. So I'll just name it Celery. Here we need to provide 2 things for the configuration. One is the broker part, and the other one is the backend part. So broker, where all of the messages will be pushed, and the backend where the results will be stored. So both of those are gonna be Redis for us. So broker and backend, and yeah, the value of this is gonna be Redis. localhost. I'm not specifying the host here because by default it would be considered as 6379. If you want, you can change it as well. But remember, if you are changing it, then while starting the Redis server, you need to specify that thing there as well. So I'm just keeping it simple. I'm using the default configuration, the default port number used by Redis. That would be 637. Okay. Now what can we do is, okay. So we can define one of our tasks. As Sanjita just demonstrated how you can define tasks in Celery. What we'll do is we'll simply say at app.task. So this app is basically what it is, an instance of Celery class. So I'll make use of this decorator in order to define my task. Now, the same way you do it in Flask, you have to define a method that will actually behave as a task. Let's name it as like sample here. Again, I'm not giving any parameters here, but if you want, you are free to do that. For just a simple demonstration, what I can do here is maybe I can return a simple message, hello world, or maybe let's do one thing. Let's return a random value. So this is going to return a random value between 0 and 1. That means a decimal or a float point decimal. This task will be returning each time it gets triggered. Okay, so this is a very basic setup of Celery. We have written all of the code that is required in order to trigger a task. Now, if we need to see that how does it work, we need to first start the Redis server. As we have already seen how you can start the Redis server by using the command redis-server and specify at what IP address you want to initiate it at. Since we will be requiring multiple terminals here, for one is let's say for one terminal we will instantiate the Redis server, other one we will instantiate Celery, and from the third terminal we'll try to invoke these tasks. Okay. So in that case, what we will be using is we will be using a utility called teams, a terminal multiplexer, because Replit provides us with just one shell, and it's not possible to do all of those things in one shell, because one will be occupied by one server like Celery, other one will be occupied by Redis. Well, you can even run Redis in the background by setting daemonize flag equals to yes, but means yeah, still we will be requiring more than one terminal instances in that case. So what will I do is I hope I have installed Tmux. Just a minute. Okay. Yeah. So now Tmux has also been installed. What this has done is this is giving me one instance of the shell, or you can say of this terminal, where I can do whatever I want. So as I said on the first one, I'll just initiate a Redis server. Redis server, what we need to do is we need to specify at what IP address we want it to be binded with. So as usual, we will do it on localhost. Right. 127.0.0.1. Okay. If you want, you can specify the port number as well, but again, by default, it would be treated to be 6379. I am not setting the daemonize flag equals to true or yes. That means it won't run in the background. It will occupy the whole terminal. That means I won't be able to perform other tasks on the same terminal. I'll have to close it first if I want to use the same terminal for performing the other task. So as soon as I'll hit enter, you will see that this Redis server has started. And at last, you can even see this message as well, that it is ready to accept the connections. Now, this terminal is occupied. I cannot write more commands here. I just need to stop it if I want to do so. But what will I do is I'll just create one more instance, making use of Tmux. So yeah, I have created one more instance of it. And in that, what will I do is I'll instantiate my Celery workers. Now, how to instantiate those Celery workers? We need to use this command called Celery -a, that's a flag. And after that, we need to specify the file name, which file name we want to run the workers on. So the file name is also Celery. After that, since we want to start some workers, I'll say workers. And yeah, after specifying the workers, what I can do is, so I can set the debug level as well. By default, it would be, sorry, not the debug level, log level. So by default, it is debug, but we can set it to something else if you want. So I'll just set it to info that is being demonstrated in screencast or in the lectures as well. So it will take some time. What does it say? Okay, I guess it is worker. Okay.
Yeah, the S.
Yeah, so it has started the task. 1 second. Not connect to.
I don't know, for some reason it's taking from 5, 6, 7 towards the 4.
Yeah, just a minute. Let me close this. This is running and okay, this is not allowing me to. Okay.
So my Redis server is not starting. It says that failed listening on port 6379.
Can you try instantiating it again?
Yes, sir, I tried. It is a Redis -server bind on 12.0.0.1, right?
Yeah, 127.
12.7.0.0.1.
Yeah.
No, not able to.
Okay, means you have installed, are you doing it on Replit or where?
Repel.
Okay, Replit. I'm not sure. Have you installed all of the dependencies that are required? Have you specified all of the dependencies here in this .next file?
Yes, sir. Can you show the Redis to start the Redis server, the command?
Yeah, what you need to do is you need to write this Redis server --bind space and then the IP address.
IP same 12.7.0.
127, not 12.
127.
Yeah.
127.0.001.
Yeah. So I'll start it once again. It says okay, ready to accept connections. Let me see. I'll go to next. To guest. Okay. Let me see what is the problem. Just a minute. Just give me a minute.
Actually, I was facing the problem in running the Celery, creating the Celery worker in the command terminal as well. It was running infinitely.
Running infinitely for users. I mean, the task is getting received, but it's not ending. That's what you're trying to say, is it?
Yeah. It's actually trying to import some files, import numbers, input M file. And then it says files frozen import leave bootstrap.
Bootstrap. Can you just try to kill that once and try to see if it's working in the solo mode? Can you just do a control C twice and just exit the Celery once?
Yep.
Then after you do that, yes, the command that you're using is use the same command. In the end, just try to append a minus minus pool equals solo.
Minus minus
Pool, yeah, hyphen pool equals solo.
Yeah.
And just try to see if it's receiving
The
an
command
error.
is celery -a
Yeah,
app.celery space worker
yeah.
space.
App.celery would depend as to how you have named your file. Okay, so if your file is file name is app, and if your celery instance is celery, then it's app.celery. Okay, so you
Yes,
need
the
to
file name
run
is map.py.
app.py, right? And the Celery instance that you've created, that's also Celery, right?
Yes.
Okay, then it's app.celery. Yeah, so if you have named your file name differently, or if your Celery instance is named differently, you have to take it differently. Okay, and then the same command, you run your worker, then you give a log level info, and then you give a hyphen pool equals solo.
Yeah, now it ran celery ad.
Okay, and has it, yeah, did it complete it? Did it give a succeed?
Yes, it's an celery address user ready. I guess yes.
Okay, but yeah, why that happened, I'm not sure at this point of time. Uh,
Just connected to
early,
Redis at the localhost 6379.
it's connected to Redis as well, right? So it
Yes.
dumped the result into Redis as well, right?
Mm.
Okay.
And what exactly is the
Okay,
minus
but
minus
yeah,
pool
that
description?
that isn't a solution. Yeah. So I mean, for some reason, if you see when the command runs up, right, you would be seeing some concurrency, and it takes the concurrency as 4. So by default, this worker can spawn 4 processes at one time. Huh? So that's the default that it takes. Uh, so yeah, I mean, it could be related to a number of things. So I need to check up on that. Yeah. So why or what is causing that problem for you? So one thing that you might want to check is like, I mean, how many cores do you exactly have on your PC? Yeah. And yeah, so the solo is not a solution to it, because what we are doing is it's not working in a concurrent mode in as such, right? So we are saying that okay, it's going to take one task at a time. But yeah, when you're taking one task at a time, it's able to handle it. So I'm not really sure why it's not able to handle it uh, in a concurrent mode for you. But yeah, I mean, I did read a few posts on the net which says that sometimes WSL gives a problem, and the same thing works fine on a Mac or a Linux. But yes, I'm not completely sure what could the issue be. We can check that out, why it's happening. Okay.
Okay, so I guess it has started working. I'm not sure why it was not working on the default port. Let me share my screen again. So I have changed this port number to 5342, and now it is ready. It is working as well. In the same way, I have started the Redis server on the same port too. Let me close this. I'll make use of tmux, or we'll start it right from the beginning again. All right. So here I'll start the Redis server, and I am using the port here as 5342. That is what I have specified in my Redis file as well. I'll start it, and it says that it is ready to accept the connections. Now I'll create a new instance of this terminal. Very sorry for the background noise. Just give me a minute. Yeah, sorry for the disturbance. Okay, so what we did was we just initiated the Redis server. What will I do is I'll go ahead and will create, or will start the Celery workers as well. So Celery A, Celery worker -L info. All right. Okay, it has again started causing issues. Not sure what is happening.
Sir, it's using port 5672. That's why.
Okay. Okay. Sorry, I have specified the wrong thing here. So I need to even go back and see.
5672. You've written 42. Abhishek, are you on mute?
Oh, sorry, I was on. I didn't realize that. So I'm just trying to see what port number is working. I'm not sure why it has suddenly started causing problem. So I have initialized the server, I guess, at 5672. I will start it again, and it is also saying it should connect to 5672. No, some issue is still there.
Sir, I don't know if that's a problem or not, but you have written 2s in task.
Sorry,
In
can you
app
please
is
repeat
equal-
again?
In app is equal to salary, you have written 2s in task. So is that the spelling right or wrong?
Where?
Sir, in line number 5.
Line number 5, I have written. No, I guess that should not be a problem. No.
Okay.
It's just a name, so it doesn't matter, but it is. Okay, let me just try with the default configuration one more time and see if it works. Let me just refresh it.
Sir, maybe use a new replit. It's polluted due to something, and a new replit will fix it.
Okay. Let's create any random one. I'll just copy the configuration files. I'll put it here. Yeah, done. Okay. Even I was shocked when I see before that it ended up happening too early. Yeah, it takes some time. Okay, all right, this is done. I'll have to create one file, say tasks.py. Okay, I'll just copy it from here. Put it here. Okay, Celery time. Well, we don't need it right now. Booker is this. And yeah, I've got task. Yeah. All right. Okay, and here we have tmux installed. Flask, Celery, Redis. Okay. Yeah, let's try to see if it works this time. Okay. Firstly, we'll install the Redis server. It is behaving a bit abnormally. Okay, I hope it has started. I'm not able to scroll up beyond this point. So I'll assume that the server has started on the default port number, that is 6379. Now I will try to instantiate Celery. Task is the file name. I want to initiate some workers and with debug level, sorry, log level info. Okay, looks like it has now been connected. Yeah, okay. So we can see that the Redis is running and the Celery worker, they have been connected to Redis as well. So now what we'll do is we will again create a new instance of this terminal using tmux. And now what we'll be doing is like Professor Nitin demonstrated in the lecture, we'll see if everything is working fine by entering into a Python shell, and we'll try to call this function. So I have started this Python shell. What will I do is I'll install everything from, sorry, I'll import everything from this tasks file. Right, okay, everything is imported. Since everything is imported, I should be able to use this function called sample random. Okay, I have imported it here. Yeah. So what will I do is I'll say that r equals to okay, everything has been imported in the scope, so I can directly call sample. But I'm not sure what is happening with the formatting here. It is disturbed. I'm not sure why. Well, anyways, we'll continue. R equals to sample. So we should be able to get some result after invoking this function. If I'll print the value of R, I'll get something, which is a random value between 0 and 1. If I'll call it again, I should be getting a different value this time. Yeah, it is something different. But yeah, of course, what's different in that? We are simply invoking a function. There is nothing specific to Celery that we have been doing here. And if we'll go back to our Celery, we'll see that it has not received anything yet. It is just sitting idle right. So now we will try to send some task to towards Celery task queue. How will we do that? Can someone tell me? If we need to make an asynchronous call, how can that be done? Yes, can anyone? Am I audible?
Yes, you're audible.
Yes,
Okay.
sir.
Yeah, can someone tell me how can we make asynchronous tasks? Okay, like we were using some methods like apply async or method like delay. So we'll try to do the similar kind of thing. The function name is sample here. What will I do is I'll say sample dot delay. Now, since I'm using delay here, it is something specific to Celery. That means this will go into the task queue and will be executed asynchronously. As soon as I'll hit enter here, I'll go back to my Celery shell, and you will see that it has received the task. You can see this. And what is the task? We have received this tasks.sample. Like SAMP is there and LE is there in the next line. Right? And it has executed it as well, and it has provided the result as 0.866 ending with 90. We will see that if we are getting the same result on our Python console as well. So what will I do is I'll say simply R. So yeah, it is basically giving me the object. How can I find out what the value this function has returned or this job has returned? Can someone tell me? If we need to know what the result of a function that is executed asynchronously, how can we achieve that? Okay, one thing is there is a attribute called status with this object. So what it can give us is that if the job has been completed, it is still pending, it has been successful or something like that. So you will see that it is giving us success. That means the job has completed. And in the same way, if I'll say r.get, so we are getting this result 0.866 and ending with 90. This is what the Celery even says. Like I'll just get back to there. You can see that 0.8665564 something something and ending with 90. Yeah. That means the first task has been executed. If we want, we can even send a new task. Let's try to send one more task. So again, I'm sending it. This time I'm hoping I'll get something different. I sent it, and the result that I'm getting here is 0.054 ending with double. This is what I'm getting on the Python console. Let's see if the Celery says the same. So I'll get back to my previous instance, and yeah, I'm getting something similar. Okay. And you can see that it should have, yeah, it received a new task here and it executed. Right? Okay, sorry, it received it here. That was the previous task. Yeah. So this is how you can start Celery and work with Redis and can send tasks. But still, the main thing is remaining that we need to integrate it with our Flask application. So if we want to integrate it with a Flask application, what will I do is I'll create one more Python file where I'll write the Flask code so that we can see something on the browser screen as well as the output. Right. So I hope I have already installed everything. Yeah. Flask. Well, again, I'm using the same name here, app. So please don't confuse between the two. What was there? It was also app. Yeah. So please don't confuse between the two. Yeah. So this is app dot route, and let us just create one route as of now, and let's create a method called begin. Okay, let's try to do something here. Now, can someone tell me that if I want to execute this task means this, I want to execute this sample method asynchronously when a user of this application visits this URL. That means the home URI. How can I trigger this method asynchronously if a user visits the home URI of this Flask application? It's very much similar what we have done here in the shell. Just the way we started a Python console, we made some function calls, we got the result. Would someone like to guess? Anyone would like to guess? Okay, looks like no.
Yes, sir. We have to import from task and then do R is equal to like task dot schedule.
Correct. Yeah, great. We need to do the same. The very first thing is, since we want to use a method which is not defined in this file, first thing is we need to import that function, or we need to import that method in whatever file it is defined, right? So that function or that method is defined in a file named tasks.py. So what will I do is I'll simply say import task. And here, what I can do is I can say task. This is what I have imported. And I know that in this tasks file, there is a method named sample. So I'll call this method sample, but I want to call it asynchronous. So what will I say is I'll say delay, something like this. So what this will do is this is gonna send a task or send this method to Celery in order to execute it. What will I do is I'll store that result again in a variable named R, and I will return R. So if I will return R, what do you think? What is gonna happen? If I'll return R here, it will return us the async object. Right? We don't want the async object to be shown on the browser in front of the user. What we want is we want to show the result. And if we want to show the result, what shall we do? We can either print, either the status or we can simply call this get method in order to get what the result is. So what will I do is I'll do both. Let's say I'll append these both here like this, and let me try to convert them into strings implicitly. I'm not sure what the type of these values would be. Right. So this is looking like a complex statement. Let me try to simplify it. Am I using an extra parenthesis here? This is the get str that. Okay, so what I'm doing is I am converting the status into a string. I am converting the result of this job into a string. I am adding both strings that I am getting, and finally the result after being converted into a string, I am dumping it on the browser on the user screen. Okay. So yeah, this is done, but I need to write some code so that I can start this Flask application. So say name and app instances app.1. Remember, since we are on Replit, we need to specify the host explicitly as 4 times 0. Port, I guess, doesn't matter right now. We can set the debug equals to true, but I guess that's okay. That's fine. Okay, fine. So now if I will click, okay, yeah. So if I'll click on run button, what do you think? What should happen?
Sir, it will fail because main.py is needed. Either you can use replit.run to configure it.
Correct. So here I'll go to .replit and I'll see that what this command is saying. That will be executed once I'll click on this run button. So it will basically print this message, welcome to Nix on replit. What will I do is I'll make slight change here so that it can trigger my app.py file. So if I want to call app.py file here, just like I initiate this or execute this Python file in the terminal, I'll write the same command here. That is Python app.py. That means whenever I click on this run button, this command will be executed. It will search for a file named app.py and will finally execute it. Okay. Let's see if I'll click on run, if something is happening or not. Okay, I clicked on run and so it says that the task is pending, but it has already given us the result. Right. So now let's try to make it more interesting. What can we do is we can go to task.py. We have already imported time here, and let's try to make it sleep for some duration. I guess 5 seconds should be enough. I hope so. And instead of this random.random, I guess what can we do is we can use and 1200. Yeah, that should, I guess, work. Okay, so if I will click on this refresh button, well, I guess I should go to the shell and show you those things. Wait. Redis server. So this is Python 3.9. Yeah, this is what is showing the Celery process. That means how many tasks it is receiving and how many tasks it is executing. So the last task that we can see here is that task.sample it received and it provided a result of 0.22839 and ending with 97. And this is what we are getting on the browser. That means this is the last task that is being executed. Now, if I'll click on the refresh, what will happen is this endpoint will again get triggered. That means we will again make a call to this function, and yeah, we'll get something in return. So let me just try to refresh it, but of course it will come with a pause because what we are doing here is we are saying that just sleep, right? So it will cause a delay of 5 seconds before sending out the response to the browser. So I'll just click on it. Just see here that we have received the task. Okay, sorry, it has been executed as well. Just a minute. Looks like we need to start it again because this configuration, we have made some changes, but this Celery worker is still running with the previous configuration. So I'll just start it, or what will I do is I'll start everything right from the beginning. Okay, I'll stop it. Yeah. To exit here.
Sir, maybe also stop the replit thing and run it again.
Yeah, sure. Okay, let me see if I have anything in the tmux right now. We still have something. What is this? Yeah. So the very first thing is we need to start the Redis server. I'll quickly do that. Redis server, and we'll bind it with an address of. Let me see if we made some changes. No, it is using the by default configuration. Yeah. So you can see that the Redis has now been started. It's saying that ready to accept the connections and all. I'll create a new instance again. And what I need to do here is I need to start the Celery workers. So Celery A, what's the name of the file is tasks. I want to instantiate some workers with log level info. Okay. Yeah, it has been connected. That means it should have been loaded with this new changes as well. We are asking it to sleep for 5 seconds and after that return a result where it simply picks a random number between 1 and 100. Okay. So we'll keep our eye on this shell and we'll click on run. So of course, if we click on run, this command will get triggered. Python app.py will get triggered and we should be able to see something on the browser. Okay. So I'm clicking on run and I'll leave this shell open here just for our notice. But okay, it will automatically shift it to here. Let us just wait for 5 seconds. It should show us the result here, the browser, and it says pending in 6, right? If I'll go to shell and you will see that it received a task. 1 second, where does it receive it? Okay, I can see this task and it is succeeded in these many seconds, 5.02 seconds, and it finally gives us the result as 6. But remember, it should have been waited for the 5 seconds, right? And it waited extra. If I click on this refresh button, you will see that this message will get changed to some other random value. I'm hoping it won't be 6 again. Very less probability of having it 6 again. So once I click on this refresh button, it should wait for 5 seconds before it refreshes the text on the screen. So I'm clicking it now. So you can see that it has received a task. It is waiting 5 seconds. And yeah, those 5 seconds have now been accomplished and it gave us a new result as pending and 48. Again, if I'll click on this refresh button, you will see that we received a task. We'll wait for 5 seconds. And yeah, it gave us a new result, 1960. Right? So this is how you can trigger your Celery jobs with Flask. Very simple setup. I have not, used any complex project structure here. Just a simple Flask file separated from the Celery workers. The Celery task. So this is the simplest configuration that you can think of right now. And if you want to start it, you can even use the similar kind of setup. Now, what can we do is we can even set some schedulers, some periodic tasks, and those can even run without using the Flask application at all. Right? For example, you need to send some reports. What you need to have is you just need to have your Celery workers run. So they will initiate that job. They will, in the backend, they will use a fake SMTP server in order to initiate some mails to their users. That maybe for posting some reminders, for giving some reports, or whatever the purpose is. So what will I do is I'll just try to demonstrate a periodic task, how this could be done. Periodic tasks in Celery. So yeah, here it is. We need to first. Okay, I can take this one. I'll paste it in the Celery file. Here it is, tasks. So our instance name is app only, so we need not worry. I'll just remove this comment or let it be here. So sender.add periodic tasks. So what it is calling is, it is calling this test, but we have a different name for our method, and that is sample. So what is this doing is, it is saying sample.s. We are not giving any arguments. Our function is not expecting any arguments. I'll delete it. And the name of this periodic task is add every 10. Right? What will I do is I'll just, comment it out now, because after every 10 seconds, we should be getting a random value between 1 and 100. Okay. Yeah, I'll just uncomment this line since we are using it. Okay. So I'll just stop this Celery process and I'll start it once again since I have made some changes. Okay. So yeah, I'll just start it. So this time we have to keep an eye on what I say on two things. One is basically to see that okay, yeah, let's do it. That's an interesting thing. Okay, I'll just hit enter. It said that yeah, it has received this task.sample, but it is not doing anything. Like you see that we have set it up a scheduled task here that should be triggered after every 10 seconds. But you can see that nothing is happening. It has just started serving, but nothing is happening. Can anyone tell us the reason?
Sir, I have another doubt. Why did we use keyword args argument in setup periodic task? Like, is that necessary?
Which one?
In line number 8, like you used KW args, right?
Yeah,
Keyword
I have just
args.
taken it from the documentation. So in case, well, of course, you need to get into those Python things that how a function argument should look like if you want to make a generic function. That firstly, there should all be, named arguments. After that, I am not even exactly sure about that order now. That firstly, you need to have all of the named arguments. Then you can have default values. Then you can have this quarks, which can accept a dictionary or key value pairs, something like that.
So it is necessary to put in there, or we can just skip it and it will work fine.
I think, yeah, it should work fine. If we are not passing any arguments, it even should work fine. So if I'll just close this and start it again. Okay, looks like no.
So the keyword arg was necessary.
It was required. Okay, let me try instantiating it again. Okay. We need to write again Celery A. The file name is task worker. Okay, yeah. So we can say it's required here. All right, yeah. So my question was that we are able to initiate this Celery process, but we have configured a scheduled task here, right? It should be triggered after every 10 seconds. But we are not able to see it here. It is not getting triggered. Can anyone tell me the reason why? Anyone?
Yes, sir. Maybe stop and start it because it's in the previous state.
Yeah, we have restarted it, right?
No, from the replit side, like the button.
This one?
Yes, sir.
No. Right now we are not working with Flask application at all. Right?
Okay.
This is a scheduled task and it has nothing to do with the Flask application. So it can keep running. No issues with it. I can even stop it. Doesn't matter much. Okay. Well, I'm not sure how many of you have already watched the screencast for week 9. No, there we are talking about these scheduled tasks, and there it has also been mentioned that if we need to have these tasks that are scheduled for some time, we need to have something called Celery beat running. Right. So in order to make these things work, we need to instantiate the Celery beat in with the help of a different terminal, which will basically keep looking for the task after some fixed time intervals that we can even configure as well. So what will I do is I'll close this right now and I'll create a new terminal, and here I will initiate Celery beat. The file name is task beat, and here is a flag that we can use here, the maximum interval. That means after how much time it should check again if there is a task to be executed. Maximum interval. I hope I'm not making any typo. Max interval. Yeah. So ideally it should be 1. Yeah, it should be checking after every 1 second, but of course you can customize it according to your needs. Is there anything else? Yeah, we can have the info level again. Okay. So if I run it, it should be creating a new file. Otherwise, it would not work fine. Let me see if it creates a file or not. Yeah, it created this file, Celery beat. So I can assume that it has started working. So you can see it has sent the task for the first time. Now, after waiting for 10 seconds, it will send this task again. We'll go back to our Celery terminal and see if we are getting any task, but we won't be getting it because we have not even started the terminal. So you can see it has sent 2 tasks. So what we'll do is we will quickly go back to our previous terminal where the Celery was about to run. I'll quickly initiate it. Celery a task worker help info. So as soon as I'll execute it, it will execute some task very fast because there were many in the queue. So you can see it is 4. Sorry, yeah, it is 11, 4, 73, 34. After waiting for 10 seconds, we should be getting a new value here, a new task. Yeah, so we got one more, 32. After waiting for 10 seconds, we should be getting one more. Yeah, 76. And if we'll go, jump to that terminal where the Celery beat is running, we'll say that we'll see that it is keep sending the tasks after every 10 seconds. So yeah, you can see it is sending. I hope they are getting triggered. It's 48, 62, 52. Yeah, they are. Okay, so this is how you can even set up periodic tasks in this manner. This doesn't even require your Flask application to be running. As you can see, I have not clicked on the run button. That means the Flask application is not being run at this moment. So yeah, this is useful. Means of course, if these are the jobs you may not have nothing to do sometimes with the web application, you can trigger them in the background and can send an alerts whenever the job is done or whenever the result is ready. So I'll close this.
Sir, if I can ask one more question regarding the project.
Yeah.
So can we skip writing open API documentation for APIs?
So how you are gonna do that then? How will you?
Like there are shorter formats, right? I can write in a markdown file.
Okay.
Because there is like too much APIs to write.
Okay. I think you can, but yeah, can you just put this query on the Discord? I'll try to clarify it there by the end of the day.
Yeah, sir, I put there yesterday, so you didn't answer there. Like I even tagged you.
Okay. Yeah, I'll look at it and I'll try to answer you by the end of the day.
Okay, maybe I will also like tag you today too, so you will have.
Yeah, just tag it again so that it come up on the notifications.
Okay, sir.
Okay, yeah. So this is how you can even use this Redis and Celery on Replit as well. But as I mentioned while beginning with this demonstration, that there is a lot more of work that you need to do in order to get this running on the Replit. Of course, if you want to do it on Replit, you definitely can. But still, we will highly recommend you to do your project on your local machines. As you know, in the beginning, we were getting some errors. I don't know what were those, some kind of port mismatch. I'm not even sure what was actually happening there. Okay, yeah. Is there anything else that you want to ask, anyone?
So this might be a trivial question, but how do you create the new shell event? I mean the REPL using team.
Since we are using tmux, there are some shortcut commands to do this. Right? You basically use a prefix. By default, that prefix is configured as control plus b. And let's say if you want to create a new instance, you use key C, C for cat. If you want to go to the previous window, you use prefix plus P. Again, the prefix will remain same. By default, it would be control plus B. For example, if I'm writing Emacs here, I came to one terminal. Now, what I need to do is let's say I'll initiate a Python terminal. Or okay, no need to do that. What I want to do is I want to create one more instance of it. So I'll first press Control plus B. After pressing Control plus B, you can leave those keys and press C. So it will create a new terminal for you. Okay, let's say I'll write something here just to differentiate. Yeah, something is happening. And if you want to go back to the previous terminal, there is a command prefix plus P. So I'll press Control P first and then P. So I'll get back to my previous terminal. If I want to get back to my next terminal, I'll press Control plus B and then N. So I'll go back, go to my next terminal. So this is how you can switch between multiple instances. If you want to list, let's say, all of the terminals or all of the instances that are running at this moment, you can press Control plus B, W. So it will tell you how many instances are running. So there are some shortcuts. You can search them on the web, or probably I can share a resource. Yeah, I'll share this resource. Just a minute. Let me see if I can find it. Okay, yeah. So I'm forwarding a link to the cheat sheet. So you can refer to this and you can try some things. Right? So this is a cheat sheet. You can get a list of all of the shortcut commands that you can try with these. Okay, yeah. So yeah, is there any question? Okay, I guess you guys have no more queries. I hope you would have learned a lot from the today's session, as I guess Redis and Celery, they both are quite difficult to understand, especially in the beginning. Hope you get a fair idea of how this can be done locally or even on the repo. Hope you will try these things and yeah, will end up enjoying these things.
Sir, I did ping you just now on Discord.
Okay, sure. Yeah, I'll try to answer by the end of the message. Okay. Hopefully, we will be having that project dedicated session next week on Tuesday. We are planning to have it on Tuesday. This couldn't happen today due to some issues, but we'll try our best to have it the next Tuesday at a regular live session timing at 5 p.m. We'll announce it beforehand by Monday. We'll announce it if it is scheduled on Tuesday at 5 p.m. Okay, I guess that's it. It is pretty much we wanted to cover in this session. Again, I hope you would have learned and would try these things on your own. Please let us know in case you face any difficulties. So I think, yeah, that's a good time to end this session. So yeah, bye-bye, everyone. Have a good weekend.
Thank you, sir.